Hello everyone, in this video we will be discussing about PyTorch. Let me quickly walk through the contents of this topic. Introduction, installation, PyTorch tensors, file extensions, modules with their examples, features, advantages and disadvantages. Let's begin our session with Introduction to PyTorch. What is PyTorch? PyTorch is Python version of Torch. It is developed by Facebook's Artificial Intelligence Research Group. PyTorch is an open source library. TensorFlow, Keras, Caffe2, MXNet, and Torch are the most popular alternatives and competitors to PyTorch. Now let's see the installation process of PyTorch. Go to the website pytorch.org. Select your preferences. Copy this and run this in your command prompt. Simply, we install PyTorch library. Let's verify whether we installed our PyTorch successfully or not. Import torch, torch.version. So here is the version of PyTorch. Let's try it with one more example. Import torch, x equals to torch.ran 5,3, print x. So it's giving us some output. Hence we are done with our verification process. So our PyTorch is successfully installed. Next topic is PyTorch tensors. A PyTorch tensor is a generic n-dimensional array. It is very much similar to NumPy arrays. Only difference is PyTorch tensors can run on the GPU, while NumPy cannot. Dimensions of tensors are also known as ranks. Next one is file extensions. We can save our models by using .pt or .pth file extension. Let's see about modules in PyTorch. PyTorch uses modules to represent neural networks. PyTorch provides a robust library of modules and makes it simple to define new custom modules, allowing for easy construction of elaborate multi-layer neural networks. In this video, we will be discussing about AutoGrad module, optimization module, and Onn module. Let's discuss about AutoGrad module. AutoGrad is reverse automatic differentiation module. This performs the back propagation starting from a variable. This variable often holds the value of cost function. Backward executes the backward pass and computes all the backward propagation gradients automatically. Hence, AutoGrad module is also known as automatic differentiation. For example, after recording all the operations performed in a recorder, we can replay it backward to compute the gradients. Let's see an example to understand this in a better way. So I am importing torch. Now I am creating a variable called DevIncept. Value will be 9. Requires grad equals to true. We use this whenever we require gradient. Now I am using a function 3 into DevIncept square. So how to calculate this? We know derivative of x power n equals to n into x power n minus 1. So we have here DevIncept. Derivative of DevIncept square equals to 2 into DevIncept power 2 minus 1. It will be 2 DevIncept. So here 3 into 2 DevIncept equals to 6 DevIncept. Now function dot backward DevIncept dot grad. So here it is 54. How it is 54? We got 6 DevIncept. So our value is 9. 6 into 9 equals to 54.
Coming to next module, it is Optim module. Optim module is PyTorch optimizer which are used to reduce the error rate while training the neural networks. It implements various optimization algorithms used for building neural networks. Types of PyTorch optimizers: STD optimizer, Adam optimizer, Ada delta optimizer, Ada grad optimizer, Adam W optimizer, Adam Max optimizer, RMS prop optimizer.
Let us conceptually understand what is Onn module. Onn module uses tensors and automatic differentiation modules for training and building layers such as input, hidden, and output layers. The module torch.nn contains different classes that help you build neural network models. All models in PyTorch inherit from the same subclass nn.module, which has useful methods like parameters, calls, and others. Let us know few things about container classes. Torch.nn.module. It is base class used to develop all neural network modules. Torch.nn.sequential. It is a sequential container used to combine different layers to create a feed-forward network. Torch.nn.module list. This is similar to the index Python list, which holds submodules in a list. Torch.nn.modules dictionary. This class creates a Python dictionary that holds submodules. Torch.nn.parameter list. This is similar to the index Python list, which holds parameters in a list. Torch.nn.parameter dictionary. This class creates a Python dictionary that holds parameters. Libraries in PyTorch. Torch Audio, Torch Text, Torch Vision, Torch Serve. PyTorch on XLA devices are the libraries in PyTorch. Let's know what are the features provided by PyTorch. Those are production ready, distributed training, robust ecosystem, cloud support, and ease of extendability.
Let's see what are the advantages of PyTorch. First one is Pythonic, leaning towards Python as its primary programming language. The next one is easy to learn. Python is comparatively easier to learn than other deep learning frameworks. This is because its syntax and application are similar to many conventional programming languages like Python. PyTorch's documentation is also very organized and helpful for beginners. Coming to next, easy debugging. As PyTorch is deeply integrated with Python, many Python debugging tools can also be used in PyTorch code. If you are getting error in your code, you can start debugging by placing breaking points using pdp.set trace. Next one is dynamic computational graphs. When the flow of data and the corresponding operations are defined at runtime, the construction of the computational graph happens dynamically. Next one is higher developer productivity. PyTorch has a simple Python interface and provides a simple, powerful API. PyTorch can also be easily implemented on both Windows and Linux. Coming to next, libraries. PyTorch reach as a fully featured deep learning library for both research and production purposes, as a large community of developers have built many tools and libraries for extending PyTorch. The final one is data parallelism. Through this, PyTorch can distribute computational work among multiple CPU or GPU cores. It allows us to use torch.nn.data parallel to wrap any module and helps us do parallel processing over batch dimension.
Disadvantages: lack of model serving in production and limited monitoring and visualization interferences. Those are the major disadvantages. This concludes our topic, and thanks for watching.